Good morning, everyone. It's still 9:47 in Seattle. So good morning and welcome to Deep Dive for IoT on AWS. My name is Vadim Jelaznikov. I'm a dev manager for IoT platform for AWS. So today we're going to focus on a couple of new capabilities we recently launched for IoT. And in particular, when we're going to talk about these capabilities, we'll try to answer these three questions. Number one, how do I extract value from my device data? And we'll take a look at one of the core components of AWS IoT, the rules engine. Number two, how do I visualize my device data? And to address that question, we'll actually talk about how rules engine can integrate with Elasticsearch and Kibana. And number three, how do I generate predictions based on my device data? And for that, we're going to do a demo of the prediction function that we launched last week, actually, that enables you to connect your IoT rules to the Amazon machine learning service. How many of you guys were in the morning session led by Kyle? Just so I know whether we need to, Kyle, you were there, I remember. Whether we need to skip it. OK, so looks like some people missed it. I'm going to do a very brief overview of what AWS IoT platform is. At the core of the platform, we have a device gateway, and that's the component that's responsible for all the routing of messages between devices as well as different components within IoT platform. Then another important component of IoT platform is device shadow. And that's the abstraction layer for the developers to be able to get the recent state of each device and update the state of each device without actually caring about whether the device is connected or not. Then we have the authentication layer. And IoT platform supports TLS, mutual authentication between the devices and the platform, meaning we know which device is connecting to us and which account this device corresponds to. And the device knows that the platform it's connecting to is actually AWS IoT. We also have the rules engine, and that's the component that we're going to focus on mostly during this session. And then we have device registry. That's the service that stores all the metadata for devices that we know about in our system. And lastly, we have the control plane, which is all the create, update, delete APIs for all the resources within AWS IoT. So going back to the first question that we're going to discuss, how do you extract value from our device data? And the answer is you use the rules engine. Clicker. OK. So to zoom in on the rules engine has the following key capabilities. First, it enables you to filter messages using certain criteria so you don't have to process noise. Second, it enables you to transform your messages so you can extract only useful data from the messages coming from your devices. Thirdly, you can react based on messages, and we'll talk about it more during our later slides. Then you can move your messages to other topics. You can also move your messages to other systems, and this corresponds to a new capability that we launched last week, which is actually 2 weeks ago, which is using Elasticsearch. And finally, you can predict changes based on trends that you can extract from your messages. And that's the capability that we launched last week, and that's integration with Amazon machine learning. So before we go any further, I just want to review quickly what the rule is. And you can think of a rule in the rules engine as a JSON document that controls how rules engine processes different messages. And always, a rule has two main components. One is the SQL statement itself. It's very similar to DSL. It's a custom SQL language that we use within the rules engine. And the second one is a list of actions. And one rule can have one or more actions, which enables you to take action based on one message and take this action against multiple services. So if you're talking about the first group of capabilities within the rules engine, filter and transform, This is how it's implemented in the rule itself. So as you can see here, in the SQL part of the rule, you can have select some elements from the payload, and you can name them differently. In this case, you select a space ID key under the status key, and you name it as a room ID. And you only do it for devices that report the temperature above 50 degrees in this case. Now, the second set of capabilities for the rules engine is reacting and moving messages to other topics. And again, in this case, this is an example rule, and it shows that in this case, we select certain keys from the payload, from the JSON payload. We name them differently, and then we only do it for the payloads that have failure set to 1. What we do next is execute a rule. In this case, we execute a republish rule, and notice it has two parameters. One is the topic, which we're going to use to republish the message, and the second one is the role identifier. In the morning, Kyle talked about the security aspect of what we do. I'm not going to go back to the overall overview of how we do security, but basically, in this case, the role that this particular rule uses enables you to republish messages within IoT. And finally, the next capability, or not finally yet, but the next capability of the rules engine is moving messages to other systems. And that's where rules engine actually excels, and we consider this as one of our competitive advantages. Today, you can transform and move your messages to the following 10 services. So I'm not going to read it for you guys, but it's basically all the main services that you want to use to empower your devices to use the full power of the cloud, of AWS cloud. Now, the second question that we want to answer, and that's one of the demos that we're going to do today, is how do I visualize my device data? And the answer is using Elasticsearch integration that we launched, I believe, 2 weeks ago or 3 weeks ago, very recently. And the basic 3 steps of using Elasticsearch integration are these. You configure your Elasticsearch domain, you use IoT rule to send device data to the domain, and then you can use Kibana to visualize your data. This is an example visualization. Actually, this screenshot was taken this morning, and if we're lucky, we're going to reproduce the screenshot live. Can I switch to my laptop, please? OK. It's a little small. Let's see. OK, good. So what I'm showing you guys is the IoT console. And specifically, I'm showing 2 things that are currently configured within the IoT console. And one of them is called car, and that's the highlighted one. I'm not sure whether you can see it or not. Let me play with the font. Car. Well, trust me, it's called car. And on the right, you can actually see that this particular thing has an empty shadow. It also has an MQTT topic that's associated with shadow updates. So if there is a message coming in that tells us that the state of this particular thing changed, then that will update the shadow. And in particular, IoT, once it receives the update message, will actually emit a success message to update success topic. So what we're going to do now, we're going to take a look at the Kibana cluster, or Elasticsearch cluster as well, that I pre-configured. I pre-configured it because it takes 10-15 minutes to provision Elasticsearch cluster, but we will be releasing a blog post that talks about how to provision your Elasticsearch cluster and connect it to AWS IoT shortly. And based on the Elasticsearch cluster, I actually configured the dashboard. So this dashboard is right now empty. So if we go back to the IoT console, what I'm going to do is actually show you the rules. And right now, I do have a rule called publish to Elasticsearch, publish to ES, that I'm going to destroy. Let's see if the gods of live demos like us today. I'm going to create a new rule. Okay, I'm going to call it the same, publish to Elasticsearch. I'm going to cheat a little bit, and I'm going to get a select statement from my gist. So these are the attributes that I'm going to extract. I also included the topic. So these are the attributes that I'm going to extract from the messages coming in. And I also want to grab my topic. So in this case, as I mentioned before, as an application updates the shadow itself, the messages, once IoT platform accepts the messages, it will emit a success message to update/accepted. And finally, we're going to use Elasticsearch action, and we're going to choose a domain, which is car. When you choose Elasticsearch action in the rules editor, we actually look up domains, Elasticsearch domains that you own, to make sure that it's easier for you to enter. And what I'm going to use for an ID is just a timestamp. So notice how you can enclose, using the $, you can actually get function from the rules engine to your underlying service that you're going to connect to. I'm going to use car demo as an index, and I'm going to use car as a type. And I have role pre-configured already, which is IoT actions role. It's important to note that in this case, this is the role that has a policy that enables IoT to connect to Elasticsearch. Without this role and the associated policy, IoT platform cannot connect to your resources, in this case, Elasticsearch. So we're going to add this action. Now we're going to create the rule. And there is a mistake. So let's see what the mistake is. I think this is it. OK. That should do it. Excellent. OK, so what we just did, we created an IoT rule that listens on a topic that gets messages once a shadow is successfully updated. Now I'm going to switch to my simulator. And what I have here is a simple Node.js script that has some access key and secret key. Don't bother memorizing this. This will be rotated. And basically what it does, it emits the updates regarding a car moving across certain roads. And it emits engine temperature, cargo temperature, RPM, speed, and battery, as well as pressure. So let's see if it's going to work. All right, so it's emitting something. So the sending part works. Let's see if shadow got updated. Here we go. So what you're seeing here is the latest status of the physical device that would be actually in the field. And you see all the keys, all the parameters of this device. Now let's see if we get, here we go. So what happened here is we configured the rule that actually extracted data from the updated shadow and then sent this data to Elasticsearch. And then I had a dashboard configured in Kibana that actually gets updated every five seconds. Let's see if we can see how the car is traveling. All right, so we're around Topeka. And it will go all the way to Denver, I believe. All right. And as you can see, this is live data coming from the device all the way through IoT platform, all the way to Elasticsearch and Kibana. All right, I'm going to stop this now. Can we switch back to the presentation, please? All right, now for the third question that I wanted to address today is, how do we generate predictions based on Amazon machine learning? And for this particular example, to illustrate this particular capability, we're going to use simulated data set that we actually generated with the assumption that we have a device that has some wear and is going to fail at some point. We don't know how the sensors on this device actually behave relative to the device being about to fail. What we do know is they related somehow. And actually, we created a simulation where we have 7 sensors. One of them is completely random, no relationship to the actual wear and tear of the device. And we generated both the train set as well as the test set. So why is it an important problem to solve? Turns out that it's a very tricky problem to solve, because if you predict a failure too soon, then you might be replacing a part that's completely viable, and you'll be losing money. But if you don't predict at all, then you're generating risk. So if it's a plain engine, people might get killed. So last week, we introduced Amazon Machine Learning Predict function. And the sequence of events, or the sequence of steps to enable Amazon Machine Learning Predict function is very simple. You use an IoT rule to forward device data to S3. Then you train your Amazon Machine Learning model using this test set or using this training set. Let me go back. Then you use another rule to actually obtain predicted values from real-time prediction endpoint in Amazon Machine Learning. And then you can emit, for example, CloudWatch metric or CloudWatch alarm. And then you can also emit, using a different rule, you can also emit details of a predicted failure. This is the syntax of this function. It's very straightforward. You basically have machine learning underscore predict, and you give it a name of your predictor. It's called in Amazon Machine Learning, and you give it a role. And the role is, once again, this role is going to be used by IoT platform to connect to Amazon Machine Learning. So it's very important for you to make sure your permissions are set correctly. OK, so we're going to do another demo. Can we switch to my laptop, please? OK. And in this case, I'm going to show you the, I hope you guys can see this. Let me just make it bigger. Let me close this one. So I actually downloaded the 2 files that I used to train this model. One of them is the train set, and it has approximately, I believe, 1.2 million data points. Yep, little over 1.2 million. And if you take a look inside, all it is basically a comma-separated value file that has the following parameters. It's the cycle of the device. It's sensor reading 1, 2, 3, 4, 5, 6, and 7, and the target. Now, the target is, since it's a training set, the target is set to 0 if the device is not to fail in the next 30 cycles. And it's set to 1 if the device is to fail in the next 30 cycles. So this is the training set we're going to use to train our model. If you take a look at the actual test set that we're going to use to see the prediction, it has just 230,000 readings, and it's actually a sample of 5,000 devices. Okay? So what I'm going to do now is go through the machine learning interface. Here's my machine learning. On this data set of 1.2 million data points, it takes approximately 15 minutes to train a model. So I'm going to show you how to start training the model, but then I'm going to skip forward to the model that I pre-trained, so we don't waste time looking at the screen. So I'm going to say create new. And I already uploaded the data. This is the training set that you saw before. I'm going to name it PM demo. Okay. What is happening right now is machine learning actually got the file. It recognized some format, and it's suggesting a schema. So in this case, since I have the headers, I'm going to say I have the headers, so get the schema from the first line. And then since I know that my target, these are the same parameters that you saw in the CSV file. Since I know that my target is actually binary, I tell machine learning that it's a binary target, because in this case, machine learning will use binary regression versus linear regression. And I must pick a target. In this case, the target is the value that we're going to try to predict. No row identifier, view, everything looks good. Review. Excellent. So what's happening right now is machine learning is actually downloading this file from S3 into internal storage, splitting this file into training set and validation set. It's typically 70%, 30%, and then training the model. It takes approximately 10, 15 minutes on a data set like this. So what we're going to do is actually use the model that we pre-trained. This is the model. And one more step that you'll need to do if you want to try it yourself is actually create a real-time prediction endpoint. A real-time prediction endpoint is a high-performance endpoint into Amazon machine learning that enables you to get a response from a trained model within 10 milliseconds, which means that you can basically get messages from your devices and do predictions real time. So we're going to do another dangerous deed. We're going to actually destroy the rule that I have, which right now publishes to CloudWatch using machine learning predict function, and see if I can reproduce it. And it's gone. I'm going to cheat again, and I'm going to get some values that I stored. So I'm going to create a new model, a new rule. I'm going to name it publish to CloudWatch. And under select, I'm going to say select everything, so it's star. Under topic filter, I'm going to use a topic that I later will use to emit data from the devices. Let me me store the metric. And I'm going to choose CloudWatch metric action. The name is this. The namespace is PM metric. The unit is none. We're emitting just numbers. Now, the value is the interesting part. So remember, I showed you the syntax for the machine learning predict function. So that's what we're going to use here. So what I'm doing here is I'm going to use the $sign to actually evaluate this expression. Then it's machine learning predict. Then it's the identifier of the model that I trained before. And then that's the Amazon resource name for the role itself. And then I'm going to send all the data from my message, extracted by the rule from my message to the machine learning. And then I'm going to extract the predict label. And if everything is in order, we should be able to add CloudWatch metric action and create the rule. Now what happened here is that now we have publish to CloudWatch rule. And if we go to CloudWatch, this is the metric that we used to configure this rule. Right now it's empty. There is no data. Needs to be refreshed within 1 minute. Now, remember the testing set? We're going to emit this testing set to AWS IoT platform at approximate rate of 80 requests per second. It will look slightly hectic. It's warming up, and it's going. Now, if everything worked correctly, then we're going to see, shortly, we're going to see a metric in CloudWatch. So what the test script is doing is taking groups of 20 devices from the test set and emitting the readings of 7 sensors for these 20 devices until it exhausts the group of 20, and then it moves to the next group. And the reason why I'm doing it this way is so we don't have to wait 10, 15 minutes because we're emulating real devices in the field. We should wait approximately 3 minutes for this alarm to actually, for the metric to change and for this alarm to go on. And in the meanwhile, if you want to have a little bit more fun, go to predict.vadimj, V-A-D-I-M-J, @.io. Let me actually show it to you. One thing we recently launched is actually a WebSocket integration. And the WebSocket protocol enables you to get MQTT messages through a web browser or anything that can talk WebSockets. So if you go to predict.vadimj.io, you should see a similar screen to mine. And if you click Connect, you should connect to IoT platform. If you click Subscribe, then you'll subscribe to the same topic that one of the rules is emitting predictions to. So in this case, if you are seeing what I'm seeing, then these are the messages that tell me, hey, turbine ID 2110, cycle number 614 is predicted to fail within the next 30 cycles. So this is the way, and this application is completely serverless, meaning there is a set of HTML and JavaScript deployed somewhere in an S3 bucket. And this JavaScript actually connects to IoT platform through a WebSocket interface, subscribes to PM predictions topic, and actually getting these messages every time machine learning actually detects a potential failure within 30 cycles. And if we go back to CloudWatch and refresh, So this particular side of things did not work. Let's see if we can fix it quickly, and if not, we'll move on. Okay. And let's see if we... Okay, well, I guess half of the demo did not work. But that's probably my typing skills. And not probably, for sure my typing skills are not the AWS IoT platform. Can we switch back to the demo, please? To the deck, please? Hey guys, can we switch back to the deck? Thank you. So you already saw that. So in summary, what we went through today is a couple of recently launched features in IoT that actually enable you to extract value from your device data. And in particular, I showed you how to visualize your data using Elasticsearch and Kibana integration, as well as how to run predictions using Amazon machine learning. Thank you guys for having me. We still have some time. So if you have any questions, please feel free to come and chat. Thank you.